I decided to split up the Learning Target 1 video into two videos because I feel like more people might need to go back and watch this current video for set builder notation and union/interval notation. And all it's going to do is take the work that we did in Learning Target 1 and in other learning targets and communicate the answer a different way. Kind of like you might pick up the phone and call somebody, or send them a text, or write an email. There's just different ways to communicate what you need to communicate. So I'll start with set builder notation and go back to the bell work problem where we had an answer of x equals 4 and an answer of x is greater than -3. For set builder notation, when the solution set only contains one number, 4, you can take a brace and an open brace and a closed brace and just put the number 4 in the middle, and that is the solution set. It's set notation because it has braces on the front and at the end. But now, that's just for one answer. When we try to put the solution x is greater than -3 into braces, that was a bad brace, it's a little more difficult to do. Let's try that again. There we go. So what we have to do is use set builder notation. We have to build a set instead of trying to list -3, -3 point, well, I can't even do a small enough decimal for it to really work. -3 doesn't work. -3.00, I'm sorry, let me back that completely up. The first decimal that would actually work greater than -3 would be -2.9999, -2.9998. You get the picture that it would be impossible to write all those numbers in the set. So you do set builder notation to relay that information. So you start with x, you declare your variable, declare the variable, and then you put the vertical bar, which when you read that out loud, you read it as such that. So far we've said our variable is x, and the x's are such that x is greater than -3. And now we've built a set of numbers, a list of numbers that start with, well, they don't start with -3, but they start with anything greater than -3, and it traps it in the set notation. So that's set builder notation. Now let's use it for our compound inequalities, example 1. We open a set, define the variable x such that. Now there's two ways we can answer number 1. Option 1, we can list it as x is less than or equal to 5 and x is greater than or equal to 1. That's an option, but with a solution set such as this one, it's easier or more condensed to write the solution set this way. 1 is less than or equal to x, which is less than or equal to 5. That's another way of saying the shaded region 1 to 5. So you're going to see your end of course questions combine x is greater than or equal to 5 and x is less than or equal to 5 and x is greater than or equal to 1. They're going to combine it into this expression, 1 is less than or equal to x, which is less than or equal to 5. Same thing with number 2. While you do have the option x such that, take this and copy it here, that would work. The book and end of course is going to combine those two to say -2 is less than x, which is less than 3. And those are kind of the two weird ones for set builder notation. Number 3, straightforward. X such that. Our answers start at 5 on our number line, so x is greater than 5. Number 4, no solution. So what you do is you open a brace and you put the symbol for no solution inside of a set, and that's called the empty set. It just means that there are no answers in this solution set. Number 5, another one that's straightforward. X such that x is less than or equal to 0. That's all of the shaded solutions. Now for an OR, number 6. Open a brace, x such that. There's really only one way to write an OR, and that is x is less than 2 or x is greater than or equal to 6. You just have to write it the long way. Write it with the word OR when you're in that section where you're defining the numbers that work. So, and it's okay if you put the first one as x is greater than or equal to 6 or x is less than 2. That's okay. I prefer them to go in smallest to largest order. But number 7 is another straightforward one. X such that your solutions are 1 and bigger, so x is greater than 1. Close that. And then finally, number 8 for set builder notation. You're going to trap all real numbers into a solution set. So you'd say x such that there's a symbol for all real numbers. So let's use that here. The symbol is kind of like a capital R with an extra vertical line. So x such that all real numbers. All right, and that's set builder notation. So I'll stop there and make a new video for interval and union notation.